Hi, in this video, I'll be giving you a brief introduction to polynomials. So the goal here is that when we're talking about polynomials in future videos or in future lessons, you'll know exactly what we're referring to when we say certain things. All right, so a polynomial is an expression that is separated by addition or subtraction. So for example, let's say we have 4x squared plus 2x minus 1. That's a polynomial because, as you can see here, each term, so that's a term, that's a term, and that's a term, and they're separated by addition or subtraction. All right, so a lot of things you'll see are polynomials. It's kind of easier for me to tell you what's not a polynomial and why. All right, so over here, let's make sure we note that this is a polynomial. Oops, let's get a better circle here. This is a polynomial. Yay us. And over here I'm going to write something that's not a polynomial. So let's say 7x to the minus 4 plus 2x plus 3. All right, so the reason this is not a polynomial, even though yes, we do have each term being added here, it's not a polynomial because another requirement is that we have to have whole number exponents. So here we have a negative number and we need whole number exponents. And when I say whole number, I mean 0, 1, 2, 3, and more. So whole number starting from 0. Negative exponents are not okay. So this here is not a polynomial. All right, so it's good to have an idea of what is a polynomial and what is not. But we're going to actually take this a little bit further and we're going to start classifying polynomials. So classifying meaning what type of polynomial. And there are two ways that we can classify polynomials. So two different categories. So we can classify polynomials by the number of terms. And we can classify polynomials by the degree. And I will make that clear really soon what I mean by that. So number of terms or degree. So number of terms just means how many things are being separated by that addition or subtraction. So for example, let's turn the page so we have more space. Okay, so first we're going to look at how to classify it using the number of terms. So for example, if we have something like 8x squared, or if we have something like 9x, or if we have something like 3, these are separate ones. Each of those is called a monomial. Mono for one, monomial. So a monomial has only one term. So we have also something called binomials. So for example, let's say you have 8x squared plus 3. Let's say, for example, you have 9x to the 4th minus 7. Or perhaps you have 2x plus 3. These, because they each have two terms, each of these are called a binomial. Bi for two, binomial. And so we also can classify by the number of terms with 3 terms, and that's called a trinomial. So for example, if you have 2x to the 4th minus 3x plus 1, that's a trinomial because it has 3 terms. Or let's say 2x squared minus 5x plus 3, again, a trinomial because it has 3 terms. So let's put that over here underneath. Each of these are trinomials. So we have monomials, binomials, trinomials. We have other categories for more terms, but no one ever talks about those, so neither will I. All right, great. So that is just one way that we can classify our polynomials. Another way that our polynomials can be classified is by the degree. All right, so let's give it a full-on title here. So, okay, so for our course, in our course, we're only going to be dealing with polynomials with one variable. So the degree of a polynomial with one variable is just the exponent. So we're focusing on the exponent of our variables. The degree of a term is the exponent. Pretty easy. So for example, so this is a side note here, we're not classifying quite yet. If we have 3x to the fourth, the degree of that is 4 because the exponent is 4. If we had 2x to the ninth, the degree of that is 9, again, because the exponent is 9. So when we are classifying a whole polynomial, not just the term, but the whole polynomial by degree, the degree is the highest exponent. I'll repeat, when classifying a polynomial by the degree is the highest exponent. So for example, we have 3x plus 9x to the fourth plus 5x. We're going to look at each of these variables. We have a variable here, here, and here. The highest exponent is 4, which means the degree of this is 4. Because that's the highest exponent. Awesome. All right, so we have one more thing to look at, and then we'll be all set to start jumping into polynomials like we've been doing stuff with polynomials our whole life. Let's keep going. Okay, so if you're ever asked to put a polynomial in standard form, they want you to clean it up. Like right now, this guy right here, super ugly, not great. We want it to be as simple as possible, and we want also the degree to be from the highest on the left to the lowest. So we want it to go in decreasing degree. So before we do that second part, let's go ahead and clean this up by simplifying it. And in order to simplify it, you may recall from previous lessons, we can use the distributive property. So we can take that 2 and multiply it by both things in that parentheses. So we can go ahead and do that. I'm going to rewrite. We have negative m squared plus 5 plus, I'm just rewriting, not doing anything yet, plus m squared. Okay? So now going ahead and doing my distributive property, we get negative m squared, nothing changed in the beginning, plus 5, and now we do the distributive property. 2 times 4m gives you 8m, and 2 times m squared gives you 2m squared. All right, so now it looks a lot better, but still not perfect. So we want to see if we have any like terms. And notice we have an m squared over here and an m squared over here. So we can go ahead and put those together, join like terms. Negative m squared plus 2m squared gives us 1m squared. So we have m squared. And there are no more like terms, so I'm just going to rewrite what we have. So this is review from earlier in the year when we were using distributive property. It feels a lot harder, but it really isn't harder at all, hopefully. Okay, so then now, in order to finish putting it in standard form, as I briefly mentioned earlier, we want to go from the highest exponent on the left to the lowest exponent on the right. So notice here we have an exponent of 2. There's no x here, so the exponent here is 0. And here there is an m, just 1. So the exponent here, we cannot see it, but the exponent here is 1. So we have to rearrange that to get from highest to lowest exponent. So we get m squared plus 8m plus 5. And now what looked pretty ugly in the beginning is now simplified and in standard form.